This lesson is covering part 2 of 10-7, special segments in a circle. In part 1 of this lesson, in the last video, we reviewed what we do when we have chords intersecting inside a circle. Now we're going to go over segments when they intersect outside of a circle. Previously, we talked about how to find angle measures, which intersect inside a circle and outside. Now we're talking about the segment lengths, okay? So basically, we're looking at either tangents or secant lines, right? A secant line actually crosses through a circle. A tangent line just brushes past and touches the circle outside in one point, right? So we're going to solve these both the exact same way. They just look a little bit different. Let me zoom in here. For the rule here, when you have two lines that intersect each other and they're either crossing through a circle or touching the circle and they intersect outside the circle, basically you're going to multiply the portion of the line outside the circle times the entire line. So here we're going to multiply AD times the entire line AE, and that's going to be equal to the other line, same thing, the portion outside the circle AB times the entire line AC. That's it. That's the whole rule. In one line, portion outside times the whole thing is equal to portion outside times the whole thing in the other line. Don't multiply outside by inside. That's wrong. It's the outside times the whole thing equals the outside times the whole thing. Right? It's the same when we have a tangent line, okay? So here, the outside portion, AC, times the whole thing, AD, is equal to, and then on the other line here, AB, the outside portion is AB, the portion outside the circle, and the entire line is AB that's outside the circle, right? It ends right here at B. So the only thing that looks different when you have a tangent line is instead of having different measures for the outside portion and the whole thing, it's the same for a tangent line, the outside portion and the whole thing. You're just multiplying it by itself. Okay, so outside times the whole thing equals outside times the whole thing. All right, so same rule all the way around. Let's jump right into some examples. Okay, so we're going to multiply this outside portion times the whole thing. 2.2 times, now the whole thing here is 2.2 plus x, right? It doesn't give us the length of the whole line. So 2.2 plus x, and that's equal to this top line, the outside portion times the whole thing, 3.3 times 3.3, which is actually 3.3 squared, right? Okay, so 2.2 times 2.2 is 4.84 plus 2.2 times x is 2.2x equals 3.3 times 3.3 is 10.89 minus 4.84 on both sides. 2.2x equals 6.05, and then divide both sides by 2.2. X equals 2.75. So we were solving for x, 2.75. It does say round to the nearest tenth, so we're going to round it to 2.8. But I don't have room here. We'll say 2.8. Okay? Number 2. 16 times 26 equals 18 times 18 plus x. Squishing it all in here. All right, 16 times 26 is 416. 18 times 18 is 324 plus 18x. Subtract 324 from both sides and we get 92 equals 18x. Divide by 18 and we end up with x equals 5.1 for that one. Next one, number 3. Here we have outside times the whole thing. This segment inside is the same length as the segment outside, so the entire segment is 16. So the outside times the whole thing is 8 times 16, and that's equal to the outside times the whole thing, 6 times 6 plus 2x. I'm telling you, don't forget to add these together because it is not the outside times the inside. It's the outside times the entire thing. Okay, so it does get confusing. All right, so that's 80 and 48, 128. 36 plus 12x minus 36 from both sides. That's 92 equals 12x. And 92 divided by 12 is 7.6 repeating, which is, we round to 7.7. I have to keep stopping and starting because I don't have a calculator, so I'm doing this by hand off to the side, and I don't want to make y'all sit through that. All right, here we have the outside portion times the whole thing. So 13 times 13. And the outside portion times the whole thing, 9 times 9 plus 5x. Okay, so 13 times 13 is 169. 9 times 9 is 81. 9 times 5x is 45x. Minus 81 from both sides. All right, so minus, it's 100. Minus 12 is, what am I trying to say, 88? 88 equals 45x. We get 1.95, but when we round, we have to round to the nearest tenth, so it's 2. Okay, next one, 6 times the whole thing. 6 times 6 plus 4x equals, there's no room to do these, equals 6 times x plus 3. That means if the outside are the same, then the insides are going to have to be the same as well. So we can just set 4x equal to x plus 3. And minus x, 3x equals 3, x equals 1. Right? Because if this times the whole thing is equal to this times the whole thing, and the outsides are the same, and the products are equal, then the insides would have to be the same as well. That's all I'm saying. Okay, and then last but not least, number 6 here, outside portion times the whole thing. 8 times 8 plus 2, which is 10, is equal to outside portion times the whole thing, x times x plus 11. 80 equals x squared plus 11x. Minus 80 from both sides, x squared plus 11x minus 80 equals 0. And I want to find all the factors of negative 80 that add up to 11. And those are 5 and 16, so negative 5 and 16. X minus 5, x plus 16 equals 0. And then, of course, when we're solving, our x value can't be negative. So if we're going to set each of these equal to 0 and solve, we get x equals 5 and x equals negative 16, but x can't be negative. So x equals 5 is our answer here. Let me know if you have questions.